Hello, and welcome to this demonstration of the CoolSpools commands needed to convert your IBM data to Excel using your existing Query 400 queries. So if we go back to basics, what is Query 400? Well, Query has been a part of the IBM mid-range servers operating system for almost 40 years. And because Query is so user-friendly, you'll find that pretty much any AS400, iSeries or IBM iServer contains a wealth of queries that's been built up over a number of years by both IT staff and end users. Now, IBM did try to replace Query 400 with a new product, Web Query, but that required a migration process to retain your existing query logic, and the Web Query product has since been discontinued by IBM. CoolSpools, on the other hand, allows you to convert directly from your existing Query 400 queries to a variety of output formats, including Excel, but also CSV and XML, without requiring any migration process or the rewriting of your existing queries. So we can see the existing queries on our IBM iServer by running the command work query, and if I look in the library demo, we can see that we have a number of queries, including one named DM orders, which we'll be looking at during this demo. If we look at the definition of that query, it's joining a number of different database tables based on customer number, state code and region code. It's also selecting the fields to output, the sorting of those fields, and it does include some report breaks and summaries to generate totals by state, with the number of orders and the total order value for each state output. Now if we press F5, we can see the output that will be generated, and we can see that there are region, state, customer and order details, together with those totals at the state level of the number of orders and the total order value. Now let's look at how we can use CoolSpools to convert that dataset to Excel. We'll start by typing in the command name CVTDBFXLSX. This is the command to convert from database to Excel, although this version of the command is only available in the latest CoolSpools version 7. If you're running an older version of CoolSpools, then you would have to use the command CVTDBFXL, which is missing a few of the latest features. When we press F4 to prompt the command, the first parameter is where we would normally put the name of the database table that we want to convert from. But in this case, we're going to put the special value *QRYDFN, or query definition. This tells CoolSpools that we're converting from an existing query. And when we press enter, you'll see that we can enter the name of the Excel spreadsheet or the stream file that we want to output. In this case, we'll just type in Excel from query.xlsx, and because I've not included a path, it's going to generate that in the current user's home directory, so /home/username. The following parameter allows us to define what to do if a file of that name already exists on the IFS. So one of the options is to replace, if we're happy that any existing file can be replaced, which is what we'll do in this case. If I press enter again and page down, we can enter the details of the query definition. So our query was named DM orders. We also need to specify the name of the library that contains the query. We could use library list, or we could just put in the library name, which was demo. And if we go down, we can specify the level of data that we want to output. If you remember, the query did contain report breaks with summaries, but we can specify that we only want the detail lines to be output to Excel, or that we only want the summary lines, or that we want a combination of the two. In this case, we're only going to output the detail lines. You may notice at the bottom of this page that there's the option to send the generated Excel spreadsheet as an email attachment as well. In order to do that, you need, as a minimum, the database and email modules of CoolSpools, or the full CoolSpools suite, which includes all modules. For the purposes of this demo, we're going to leave the parameter as no because we don't need to send this as an email. So all we need to do then is press enter to run the conversion, and here's the Excel spreadsheet that's been generated. So the content is the detail lines from that query, DM orders, and you can see that some basic formatting has been applied. So our header lines are in bold, and the columns have been automatically sized to fit the data. The text in the column headings has been automatically created by CoolSpools based on the query and database setup, and those report summary lines, the totals, have been excluded. Now we're going to rerun that same command, convert DBFXLSX, but this time we're going to output to the same file name, but instead of replace, we're going to specify add, and that will add a new tab or new worksheet to the workbook. And if we page down, we can change the output type from detail to summary. So this time we should just see the total lines by state. By default, our new tab will be called Sheet 2, but if we page down to the Excel options, we can specify the name, so we'll call the tab Summary. And now when we rerun that conversion and reopen our Excel spreadsheet, we can see that there's a second tab named Summary, and this tab contains the state level totals of the number of orders and the total order value. So hopefully you can see how straightforward it is to convert from query to Excel using CoolSpools. Now we're going to look at some of the more complex scenarios, and to do that we're going to work in a CL program. This makes more sense as an approach once the conversion becomes more complex, especially if it's a process that you're going to run on a repeated basis. So here is that same convert DBFXLSX command within a CL program source, and you can see that there are a number of additional parameters that we've specified this time, although we're still specifying the parameters we saw earlier, the special value asterisk QRYDFN, the query definition, and the fact that we want the detail lines. But the additional parameters we're specifying here apply different styles or formatting to the Excel cells in our resulting spreadsheet. We're using the parameter apply styles to apply a style named bold ID to Excel column E that contains the customer number, and we'll see in a second what that bold ID formatting should do. We're also applying conditional formatting, which allows us to apply different formatting depending on the content of cells. In this case, we're adjusting the background of our order total value to red, amber or green depending on its value. So orders with a value under 1000 will have a style of red, and those with a value over 5000 will have a style with a value of green. Now if we run the command work style definition, we can see the style definition named bold ID, and all that's doing is changing the font to be bold. Here it says bold asterisk yes, and if we page down, it's using Excel style formatting to ensure that leading zeros are included in our customer ID. Then if we press enter and go back to the list, we can see that there's also the red, amber and green style definitions, and here you can see the background colour is specified, and so that's allowing us to control the background of those cells. Now if we run that CL program and look at the resulting Excel spreadsheet, you can see that the customer ID or customer number column in E is bold and contains leading zeros, and the background colour of the order total column has been set depending on its value. Now let's look at another example. Something we've been asked from time to time is whether CoolSpools can generate the Excel spreadsheet with charts included. And while CoolSpools cannot directly generate charts in Excel, there is a workaround for this. If you use CoolSpools to convert your data to Excel, then you can manually add a second tab and create charts within the second tab based on the data in the first tab. So here's an example where the first sheet, named Data, has been created by CoolSpools and contains our summary lines with the totals by state. We've manually added a second tab, and that second tab contains a pie chart, and the pie chart is based on the data in the first tab, Data. What that means is if we then rerun our CoolSpools conversion and tell it to replace the content of the Data tab, then our chart will automatically be updated to reflect the latest extract of data from CoolSpools. Now, for our final example, we're going to look at converting from query to Excel using a database map. Now, using maps is quite a complex topic, so we're only going to touch upon it in this demo. Use command work-dbfxl to view and maintain the Excel maps on your system. And here you can see we have a map for the DM orders query, and like the conversion command, you can specify the special value of *QRYDFN for the source of the data, and we can specify the name of the query. If we specify option 8, that allows us to see the row groups that are going to be output to Excel. So in this case we have a header section and a detail section. Option 9, against a row group, allows us to see the cells defined within it. So our header section just contains some static text for our column headings. And if we do the same for our detail lines, then that row group just contains the data values that correspond to the headings in the previous group. So this is quite a straightforward map. You can do much more complex things like adding row groups for different totals and subtotals, and headings and subheadings. One thing we have done here is we've told it that whenever there is a new heading, and there should be a new heading for each change of state, we want to output that to a new tab within the Excel spreadsheet. Now if we look at the command to use the map, we're still using the same CVTDBFXLSX command, but this time we're specifying *map as the source of the data rather than query definition, because it's the definition of that map that tells CoolSpools to source the data from the query. When we run that program, it's going to generate this spreadsheet. So you can see we've got the simple heading and detail line structure that's been specified within the map, and a separate tab has been generated for each state within the query output, as was specified within the map definition. I hope that this has been a useful introduction to the possibilities of converting your IBMI data to Excel using your existing queries. To find more information on the commands shown and the rest of the CoolSpools application, please visit our website www.coolspools.com.